The dissolved oxygen test is one of the most important tests that you're going to be doing out in the field. One of the most important parts of that important test is collecting a really good water sample. So you're going to be using a 500 milliliter glass BOD bottle. And the important thing is that you want to get this bottle submerged all the way under the water with no air bubbles and actually stopper it when it's submerged under the water. After that point in time, you're going to start the procedure using what we call the alkali iodide azide method. There are three different chemicals in the dissolved oxygen test kit that you're going to use. It's actually labeled a digital titrator. Each of those chemicals is clearly labeled, and like the other hot tests that we use, the chemicals are all pre-measured. For these chemicals, you have little plastic powder pillows, and you're going to have to use the scissors that's in your kit to cut those open. Make sure that you get all of your garbage properly disposed of. So read the directions carefully for how you're going to treat that water sample. And towards the end of that then, what you're going to do is actually add a starch solution that is going to turn, you're going to have an iodine chemical in there, and so the starch solution that you add is going to turn your solution a dark blue or purple. You're going to have measured out from your BOD bottle using the plastic graduated cylinder. You also need a plastic Erlenmeyer. So you need those three pieces of lab equipment in addition to your blue kit to do dissolved oxygen. You're going to measure out a certain value of sample into your 250 milliliter Erlenmeyer, and then you're going to use 100 milliliters of it. You're going to add a starch solution to that, and notice that you are adding 2 1 ml droppers. This is really important. 2 milliliters or 2 1 ml droppers. And so when you open your starch solution and you squeeze it to fill it with starch, it's automatically going to go to the 1 ml mark. You just add that twice. And then what I'm going to do is use something called a digital titrator to express my titrant. So we're going to titrate our blue solution to a colorless endpoint. The titrant, or the chemical that we add, is in this little cartridge. I'm going to take a J-hook out of my kit, take the cap off the cartridge, don't lose that because you have to put it back on, insert the J-hook into that, and then on my cartridge it has a plunger I can depress to slide this barrel. I obviously want that in the way back position so that I can carefully slide in my cartridge. You'll see that there are like flat sides, so it can slide in there completely. Make sure that cartridge is all the way back. And then I want to push the cartridge up a little bit to expel just a little bit of chemical so that I know it's coming out. This J-hook, make sure your cartridge is zeroed. This J-hook can go directly down into the solution in the Erlenmeyer, and then you're going to actually dispense the chemical not by pushing the plunger, because that would push it out really, really fast, and I want to make sure I don't miss that colorless endpoint. So I'm going to slowly, I can hook this around my hand, and I'm going to slowly turn this dial to dispense the chemical. When I'm done, I want to make sure that that plunger is manually slid all the way back so that I can pull that cartridge off of there. Obviously, if that plunger is up pushing the chemical out of the cartridge, I can't take the cartridge off. So I have to manually move that back down.